Okay, so this is the last section that we are going to do in this course. So we have already solved a lot of trigonometric equations. Some were simple, basic, and then there were some which were a little complicated, and then we converted them into simple basic equations and solved them. Now we are going to look at a little more different kind of trigonometric equations. We can say more complicated, but this in example 1 we will be looking at something I would call like some special trig equations, because these will be done a little bit different way. So first example, sine of theta plus cosine of theta is equal to 0. Now you can do it in this way. You can say, okay, so I have to have this must be equal. How can the sum of two things be equal to 0? When both of them have the same value but opposite sign. So if, for example, if I say a plus b is equal to 0, so it means b must be equal to negative a. So which means b is the value of b is a, but in opposite sign, with opposite sign. So when does that happen? When do they have equal sign or equal value at theta is equal to pi over 4? So when theta is equal to pi over 4, remember sine of theta is square root of 2 over 2, and cosine of theta is also square root of 2 over 2. But we want to have them opposite signs. So when will that happen? When we are in the second or the fourth quadrant and our reference angle is pi over 4. So which means when your theta is pi over 4 or not pi over 3 pi over 4 or 7 pi over 4, but they go in the same line. So for general solution we can just say 3 pi over 4. So theta is equal to 3 pi over 4 plus 2k pi, and then theta is equal to 5 pi over 4 plus 2k pi. But actually these two can be combined and written as theta is equal to 3 pi over 4 plus k pi. Another way of looking at this, of the solution of this equation, is by writing, so I'll do it over here. So now we can write from here, I can say sine of theta is equal to negative cosine of theta. And now divide by cosine of theta. So the left hand side becomes tangent of theta and the right hand side is negative 1. So now we are looking for theta when its tangent is negative 1. So remember, this is going to happen in the first or second or the fourth quadrant. So from there we get theta equal to 3 pi over 4 plus k pi, because remember the period of tangent is pi. So this will be so you can do it either way. Same kind of similar thing with the next example. So sine of theta minus cosine of theta is equal to 0. So we want them to have exactly the same value and the same sign. And when will that happen? So from here we see that sine of theta is equal to cosine of theta. So we want them to be equal. And when will that happen? When theta is pi over 4, or when theta is 5 pi over 4. But again, if you draw them, they lie on the same line. So pi over 4 here and 5 pi over 4. So when we use the general solution, when we write the general solution, we can disregard this answer and say theta is equal to pi over 4 plus k pi, instead of saying plus 2k pi, just k pi. And we can do it the way that I showed you from here. If you divide both sides by cosine, we end up getting tangent of theta equal 1. And remember, the solution for that is pi over 4 plus k pi, which is the same way we got here. Okay, now looking at the next one. So this one also a little bit different from the previous, but so this is the one we are looking at. Now let's move the cosine on the left side. So I get sine of theta plus cosine of theta is equal to 1. Now we cannot do it the way we did the first and the second, because if I divide by cosine, I'll get tangent plus 1 equal to secant, and we don't have any identity for that, or we cannot simplify that. So how do we do that? One way again is just to think that we want the values are such for sine theta and cosine theta that when we add them we get 1. Now if the only way time, 1/2 plus 1/2 is 1, right? 1/2 plus 1/2 is 1. But can sine theta and be half and cosine theta be half at the same time? No, that doesn't happen. The only time they are same is when they have the value square root of 2/2 or negative square root of 2/2. But that doesn't work. So that won't give us 1. So if I do square root of 2 plus square root of 2/2, I will not get 1. So that won't work. So the only thing that can work is we can think about when theta is 0. So sine theta is 0 and cosine of theta is equal to 1. So this can be one of the solution. What is the other one? Theta is equal to pi over 2, and then so at that time sine of theta is 1 and cosine of theta is equal to 0. So that will work. So these two will be the solution. What about 3 pi over 2? At 3 pi over 2, remember, the sine is -1, cosine is 0. So we will end up getting negative. If we plug in the equation, we get -1 is equal to 1, which is not correct. So, and similarly for pi, it won't work. So this is our solution. So we can say theta is equal to 0, or theta is 0 plus 2k pi, which means just 2k pi. So and the other one is pi over 2 plus 2k pi. Now another way of doing this problem is a longer way. Square both sides. If I square both sides, I get sine, so I am squaring this equation. So I get sine square theta, and then we have 1 minus cosine theta whole square. So I'll get 1 minus 2 cosine theta plus cosine square theta. So now this is a quadratic type equation. So we can see the linear factor is cosine theta, linear variable, and so it means I should make it a quadratic in cosine theta. So which means I replace the sine square theta by 1 minus cosine square theta. Now, moving everything to one side and making the other side 0. So I'm going to make the left hand side 0, means I'm moving everything on the other side. So you will see when we subtract the 1 and 1 cancel out, but the cosine square gets added there. So it becomes 2 cosine square theta and then minus 2 cosine theta. So this is what we are left with. How do we solve that? We can factor here. So we get 0 equals 2 cosine theta times cosine of theta minus 1. So now we've set each factor equal to 0. So 2 cosine theta equal to 0, and then the other one will be cosine theta minus 1 equal to 0. So this will give me basically cosine theta is 0. And when will that happen? When theta is pi over 2 or 3 pi over 2 plus k pi plus 2k pi. And this other equation, this will give me the cosine theta is to be 1, so that theta is 0 plus 2k pi. Or theta equals just 2k pi. Now note here that these two can be combined. Why? Because from the first one we are getting, every time we complete a circle and we arrive over here, that is a value. Also, completing a circle and arriving on this side is also good. So this is making one line, means pi. The difference between these two values will be pi. So these two can be combined and written as theta is equal to pi over 2 plus 2k pi. So in other words, if you think about it, it's going like this. So this is pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and so on. So note what the values I said: pi over 2, 3 pi over 2, 5 pi over 2, and so on. So what is this? If you look at these numbers, this list of numbers, these are, you can say, odd multiples of pi over 2. So pi over 2, so 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on. So we can actually say that theta is equal to an odd multiple of pi over 2. So how do we write it? we write it like this: 2k plus 1 pi over 2. What is 2k plus 1? This is a expression that denotes an odd number or odd integer. If you take any value to k, you will end up getting the odd number. So let me show you, for example. So look at 2k plus 1. Okay, now remember, k is to be, in all these cases, k is equal to 0, plus minus 1, plus minus 2, and so on. So if you take k is equal to 0, so let's make a list of it. Okay. So when k is 0, we get 1. When k is 1, so 2 times 1 is 2, plus 1, 3. When k is 2, you get 2 times 2 plus 1, 5, and so on. So notice, when I am giving the integer values to k, what I am getting back are odd integers. Let's try some negative values. So negative 1 will give me 1. Because when we talk about integers, set of integers, we talk about the positive integers and negative integers, and also 0 included in there. So, and when we talk about odd integers, then it means the odd, positive odd, and negative odd. And similarly, for even integers, we include positive even, negative even, and we include the 0 in there as well. So negative 2 will give me negative 3, and so on. So you see, we are getting a, so negative 3 times 2, negative 6, plus 1, negative 5. So always we are getting an odd integer. So that's how we represent this. And 2k pi, just 2k pi, we had the solution over here. 2k pi, this represents, so 2k represents an even integer. Okay, maybe in future you will need this information, so that's why I'm just. So if we do the same thing with 2k, when k is 0, the value will be 0. So because I said 0 we include, when k is 1, the value we plug in here, 2k, you get 2. K is 2, you get 4. K is 3, you get 6, and so on. Now if you try some negative values, so negative 1, negative 2, negative 2 gives you negative 4, and so on. Negative 3 will give you negative 6. So if you look at the second row, all numbers are even. Okay, so again, this example as well we can do by the other form. What was the other way? By writing, by thinking. Yeah, so our final answer was over here. So I will write the final answer, which was theta equals So in this example, the final answer would be theta is equal to 2k pi, or theta is equal to 2k plus 1 pi over 2. Now looking at the next example, which is quite similar but not exactly. So here we have, previously we had sine of theta equal to 1 minus cosine theta. Now I have sine of theta equal to 1 plus cosine of theta. So let's do the same thing. We bring the cosine theta on the left side. So we end up getting sine of theta minus cosine of theta equal to 1. So again we look at it in two ways. So first, how can I get a 1 by subtracting these two? Well, if they are, we can do that if they have equal sign. So when do they have equal to sign? At when we cannot do it when they have equal sign. Even if they have equal and opposite, like the example before, you cannot have that situation. When they have equal value and opposite sign, the numbers do not, when you add those, you do not get 1. So you have to think of it like this. Okay, what happens when theta is 0? So like we did before. So when theta is 0, sine of theta is 0, cosine of theta is 1. So can you see what you will end up getting? So you'll get, plug it in, you get 0 minus 1 equal to 1, which is not correct. So this means theta cannot be 0. When you plug in, you get 0 minus 1 equal to 1, which is not true. Next we can try theta equal to pi over 2. In that case, sine of theta is 1 and cosine of theta is 0. So that will work. So it means one of the solution will be this one. What about next thing? Let us look at pi. So if you notice what I am doing, I am looking at angles over here, here, and these values, because I know none of the angles in here or in here or in here or in here will work. So now this will give us, when I plug in, I get 1 okay, sine of theta is for pi is 0, cosine of theta is equal to negative 1. So when I plug in, I will get 0 minus 0 minus negative 1 equal to 1, which is true, because negative is positive. So we get 0 plus 1 is equal to 1, which is true. So it means pi is going to be another solution. What about 3 pi over 2? Well, at 3 pi over 2, sine will be negative 1 and cosine will be so when you plug in, you are arriving at this equation, which is not correct. So this cannot be the solution. Therefore, the solution is pi plus 2k pi, and the other solution will be theta is equal to pi over 2 plus 2k pi. Now note here, we cannot say now that it's going to be just the odd multiple of pi over 2. Why? Because now we are always getting, when we get here, then we get, that is the value of theta. We are not stopping on the line, the vertical line below the x-axis, or at negative pi over 2. So the only time you are getting your solution is when you have pi over 2 or the whole circle complete, which means 2 pi plus pi over 2, and then 2 pi plus 4 pi, pi over 2 plus 4 pi over 2, and so on. So this is our solution. Okay, so one more question of this, not exactly of this type, but like a special kind. So if you have something like this, now we have tangent in there and we have sine in there. The first thought that might come to your mind is to convert the tangent into sine and cosine, write it like sine x, so sine theta over cosine theta, but please don't do that. Just wait and look at the equation carefully. Can you see some resemblance there? By resemblance, I mean to say, can you see something like on the left hand side and right hand side, something is same? If you can see that, then you might be able to move forward and try to get the solution. If you look at the left hand side, there is a term tangent theta that can be factored out. So when I factor out the tangent theta, I am left with 2 sine of theta minus 1 equal to, now if you look at the right hand side, we have 1 minus 2 sine of theta. So if you compare these two, what is the relation between them? 1 minus 2 sine theta and 2 sine theta minus 1. So can you see these are the opposite of each other? Okay, good. So now what we will do, we will not divide by this term 1 minus 2 sine theta, but we will bring everything on one side of the equation and make the other side 0. So I will keep this my left hand side as it is, tangent of theta times 2 sine theta minus 1 so I will have 0 on the other side. So now, if you notice, this and this, they look similar. So I will factor them out. So I can factor out 2 sine of theta. I mean, if you want to rearrange this, first maybe let's rearrange. So plus okay, so now you can see we can factor out the 2 sine theta minus 1. Then we are left with tangent of theta plus 1 equal to 0. Now you set each of them equal to 0. So the first one, 2 sine theta minus 1 equal to 0 will give me sine of theta is equal to 1/2. Which gives me theta equal to, remember, pi over 6 plus 2k pi, and then 5 pi over 6 plus 2k pi. Okay, so we get theta equals so theta equals pi over 6 plus 2k pi, and theta equals 5 pi over 6 plus 2k pi. So this is a solution of one equation from the other equation, which is what? Tangent of theta plus 1 equal to 0, which means tangent of theta is equal to -1. And when does that happen? That happens when theta is 3 pi over 4 plus k pi. So these three values make up of our solution. Well, let me move this a little bit closer so that I can box them. Okay, so this is our solution. Okay, I'll stop here because in the next video we will talk yet another type of these trig equations, which are not hard, but they have something new.